Okay, so functions, we are going to go ahead and move on. We're going to do this problem. This is a really good example of a problem that could be on the test. Also the next one too. This is solving. So this one we want to start with factoring each of the denominators. So if we factor the denominators, we're going to end up with, this one is going to be, the factors of -6 that add to 1 are, oops, there we go, x plus 3, x minus 2. This is a difference of squares, and we're going to have x minus 2, x plus 2. And the factors of 6 that add up to a positive 5 are going to be x plus 3, x plus 2. Okay, so if we factor all of those, then we want to figure out what value of x is going to make this 0. So the value of x here that will make this 0 is -3. The value of x here that will make this 0 is positive 2. So I did all of that. So these are just the factors. I'm just showing you how I got to 0 that does not equal. And then again, remember we have the set notation for domain that you'll see in your homework. But then we also have the one that I'll accept on the test. And then we have our LCD. So we have x plus 3 and x minus 2 from the first denominator. There was an x plus 2 that wasn't in the first denominator, that's in the second denominator. And then the last denominator, because we have to consider all three, had x plus 3 and x plus 2, so I don't need to write that again. So that's my LCD. So we're going to use that to get rid of all the denominators. So here, I'm going to multiply, and remember, we want to keep this factored. So this is x plus 3, x minus 2. This is x plus 2, x minus 2. And this one over here is x plus 3, x plus 2. Okay, so now what we're going to do is whatever is not in the denominator is going to be multiplied by the numerator. So I'm going to have an x plus 2 here. And these right here are going to cancel. So this is going to cancel with this one. And this is going to cancel with this one. And then I'm going to look at this one. And I need an x plus 3 here. And that's going to cancel to that one. And this is going to turn into a big one with this one right here. And then we're going to do the same thing with this third one. This is a big one right here. This is the big one right here. And so I'm going to have an x minus 2. So then when we have that, now I just have my numerator since all of these turned into 1s. And now I need to distribute all of these. Make sure you distribute that negative to both parts. And then I'm going to distribute here. So then we end up with 4x plus 8 minus x minus 3. And then we need to combine like terms. Now I'm just doing solving. I'm going to subtract 5 from both sides. So if you subtract 5, and you add, subtract 2x minus 2x, you get x is equal to -9. So now we just have to make sure that it fits in the original solution set. So remember, our original solution set, oops, too far, says in our domain, it's going to be every possible solution, but if it's -3, -2, or +2, not going to work. And -9 is not one of those, so the solution set is going to be -9, meaning the answer is -9. All right. So we are going to do the same thing here. So x plus 3 is going to be one of my LCD factors, x minus 1. This right here, the factors of -3 that add to a +2 are x plus 3 and x minus 1. So I have that here. And then the third one, since this factors to that, I don't have to worry about it. So then my solution set is all real numbers, all possible values such that x does not equal -3 or a 1. So now we're going to use our LCD, because remember it came from the first denominator, second denominator, and this one had both of them in it, so I didn't have to worry about it. Okay, so now we're going to use that information to help us get rid of the denominators. So I'm going to multiply everything in this rational by my LCD. So I'm going to multiply this whole thing by x plus 3 and x minus 1. So now anything so if I multiply that, I have this over this, which is a 1, but I'm left with that, so I'm going to have x minus 1. And then I have x minus 1, so this and this, so this cancels. This canceled, and I'm left with x plus 3. And then these are both in the LCD, so they cancel. So the thing that I'm left with, is I'm left with 2 times x minus 1 minus x plus 3, and that's going to be equal to negative x squared minus 3x. So then what I'm going to need to do now is I need to distribute. So I've got the 2, so I end up with 2x minus 2 minus x is negative 1 times x, and then minus 3 is equal to negative x squared minus 3x. And then I need to combine my like terms, so I'm going to do that. So I have got 2x and an x, so that ends up being just x, and then negative 2 and negative 3 is negative 5, and then these are different, so I can't combine them. All right, so now I've got everything, but I do have a quadratic. And to solve a quadratic so I can solve for x, I'm going to need to get this whole thing equal to 0. So I'm going to add x squared, add 3x, and I'm going to do that over here. So plus x squared plus 3x, and I end up with x squared plus 4x minus 5 is equal to 0. Now I can factor it and solve for 0. So the factors of negative 5 that add up to 4 are x minus 1 and x plus 5. And so then I set each one of those equal to 0. So I'm going to have x minus 1 is equal to 0, plus 1. Oops, that's a plus. So I get x is equal to 1, and I have x plus 5 is equal to 0. Subtract 5 from both sides, and I get x is equal to negative 5. So if that's the truth, if I have x minus 5 or x is equal to 1, I've got to remember my domain. And remember, in the domain, 1 was not part of it. It says it right here. X cannot equal negative 3 or 1. Well, I've got a 1 here, and this is what we call an extraneous solution. So an extraneous solution means not a solution. The only solution for this one would be negative 5. So negative 5 is the only possible solution in the solution set. So in your homework, it's going to ask for that. It's going to ask for the solution set, which would just be negative 5. 1 is an answer, but it's not part of it. It's an extraneous, it's an extra solution that technically works, but will not work in this, works algebraically, but will not work graphically, essentially. So if you have any questions on this, please come to class with questions. Otherwise, we will be reviewing, and the test is on Tuesday. Have a great night.